This video will introduce an approach called Developmental Embodied NeuroSimulation. This approach was developed at the Orthogonal Research and Education Lab, there's our website, and it was developed by about 10 co-authors at various levels of contribution. So we start off with something called developmental Breitenberg vehicles, which takes the Breitenberg vehicle and it turns it into a developmental system where the body and the brain are developed in tandem. And so you can see here that you have an adult Breitenberg vehicle laying an egg, it differentiates into a new adult, and you can modify that developmental process in different ways. The next approach that we use is Gibsonian information, and this is another preprint from the PsyArchive, and you can see that we characterize information as an external distribution of different states that's encoded into an internal communication channel, which roughly corresponds to an internal model and an agent, and then is decoded into behavior. We also turn to continual embodied learning, which is an approach where we probe this developmental Breitenberg vehicle a little bit more, and we explicitly introduce the concept of a genomic encoding, which serves as an innate mechanism for specifying different parts of the nervous system. So here you can see that we specify different cells, their birth times, and even maybe their death times as well, so that we have this nervous system that's changing in development and then ends up giving you an adult nervous system that's been developed. We also turn to something called Metabrains, which is another preprint from the archive. This is something that involves layering different types of representation, different levels of representation, so that you can have a neurosymbolic type system, but something that interacts and you can turn different layers on and off as you need to. Finally, we have this approach of inheritance and learning. So this is where we partition the genetic and cultural components of inheritance and learning. Thank you for your time.